Today we're going to be discussing how to work with decimals and percents. These are essential for most real-world scenarios. You will be constantly running into decimals and percents in one way or another because it allows you to represent a part of a whole, and in particular the most common representation for the part of a whole whenever it comes to applied settings. In order to do this effectively, the first thing that you want to always think about is what the heck is this decimal actually conveying? Now keep in mind that in other cultures, sometimes they actually don't use a point to be a decimal, but in standard English we do. In particular, if you come from a Spanish-speaking culture, you may be used to the number 17.75 being represented as 17,75. This is tomato, it's just how we represent it in English, but you will not see the comma representation in English standard math notation. The comma instead is how we indicate higher value whole numbers. But without further sidebars into how Spanish works, let's talk about the number 17.75. How do you actually interpret that? Well, if we have the number 17.75, place value-wise, the 1 is in the tens, the first 7's in the ones, the second 7's in the tenths, and the 5 is in the hundredths. So what this really means is 10 plus 7 plus 7 out of 10 for the 7 tenths plus 5 out of 100 for the 5 hundredths. Now that would be a lot to say out loud. You'd have to say a 10, a 7, 7 tenths, and 5 hundredths. So how do we say that more concisely in English? Well, we would say 17 and 75 hundredths. It's a lot faster. Instead of saying 7 tenths plus 5 100ths, you can use your fraction operations to have this have a least common denominator of 100. To give you 70 out of 100 plus 5 out of 100 for a final answer of 75 hundredths. So in short, whenever you're translating, you want to pay attention to what is kind of the deepest decimal, and that will tell you sort of the overall units. So for example, on this next number, 0.204, since the deepest decimal is in the thousandths place, so fractions over 1,000, that means that the way that we concisely say this is 204 thousandths. So the number 204 thousandths would be what that is depicting. Go ahead and pause this video and do a quick check for your understanding on yourself on how to translate the following phrases. So in particular, 15.43 would be 15 for the whole number part, and let me actually write it out completely, 43, and this last place value is hundredths. So that is 15 and 43 hundredths. Now let me get rid of that. Okay. Which number has a 5 in the hundredths place? So hundredths place is the second decimal place. That would be the answer C and answer D. So 0.45 is 45 hundredths. 12.05 is 12 and 5 hundredths. If you're comparing these two 4s, this first 4 is 4,000 versus the second 4 is 4 tenths. So when the 4 comes after the point, that is indicating the decimal. That's indicating the fractional part of the number. In order to graph decimals on a number line, now what's written out here is really the very, very formal way that you do it, but let me kind of demonstrate in words. So if you want to plot 0.03, for example, you would really plot this the same way that you would plot its fraction equivalent of 3 tenths. So the 0.3 is indicating this is a number between 0 and 1. If you were truly estimating, you would just kind of say, hey, he's going to be a little bit closer to 0 than 1, put a 0.3 there. We're maybe going to be a little bit more precise, at least for this one, and indicate, okay, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. I made 9 tick marks to break it into 10 pieces. 1, 2, 3, so 0.03 would be here. So 0.3, aka 3 tenths. Now, if you're going to be super precise, if I were to plot something like 0.33 instead, what I would then do is break in between all of these tick marks into an additional 1, 2, 3, 4, 5, 6, 7, I can't even quite fit it, but like into 10 equal pieces. That would be if you're being super precise. That is a lot to do by hand. So I would say, even though this is giving you sort of the precise way to do it, this would be a lot to do. And in most contexts, it's going to be okay to estimate. And what do I mean by estimate? Well, if I have the number 0.33, first of all, would that be closer to 0.3 versus 0.4? It's going to be a little bit closer to 0.3 because it's a number that rounds down to 0.3, and it'll specifically be approximately a third of the way between 0.3 and 0.4, and that would be about 0.33. For the purposes of most classes and sort of visualizing for yourself, as long as you can estimate where it should be approximately on the number line and visualize that for yourself, that is a-okay. And that's similarly how we're going to deal with plotting negative 0.75. So on a number line, we'd be between 0 and negative 1 this time. And negative 0.75 would be about 3/4 of the way, or right between 7/10 and 8/10, closer to negative 1. I should really say in between negative 7/10 and negative 8/10. And if you want to at least be precise about the 0.7 part, what you would do is break this guy up into, again, 10 equal pieces. That's where I ran out of room. 9, so we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, yep. And then 1, 2, 3, 4, 5, 6, 7. So negative 0.7 is here. Negative 0.8 is here. Keep in mind that, we're counting to the left when we're counting negative numbers. And negative 0.75 would be right there halfway between negative 0.7 and negative 0.8. Go ahead and try these next two yourself, keeping in mind, and I'll help you get started with at least the whole number part, that 1.56, for example, won't be between 0 and 1 this time, but between 0 and 2, and that negative 8.34 is going to be counting 0. There's going to be lots of numbers in between, negative 7, negative 8, negative 9, negative 10. It would be in between negative 8 and negative 9 because you're counting again to the left. So go ahead and pause this video and see if you can go ahead and at least estimate where these would be. If I'm going to estimate where these would be, 1.56, if I were to sort of mark the in-between of 1.5 being exactly halfway in between 1 and 2, 1.56 would be just ever so smidgen to the left. To the right of 1.5, and it would specifically be approximately halfway in between, but slightly closer to 1.6 perhaps would be here. You also could have formally divvied this up into 10 equal pieces, but if we're just sort of estimating, this is sort of what I would consider a good approximate estimate of where 1.56 is, because really this is just a visual that you want to keep in the back of your mind so that you have good number sense on where these numbers should end up. Pretty similarly, if I wanted to plot negative 8.34, I would just shimmy this just a little bit to the left of negative 8 and a little bit closer to the negative 8 than to the negative 9. Again, you could have formally broken them up into 10 equal pieces, and then this would have been between negative 8.3. Let me just actually write that. Negative 8.3 would be over here, and then negative 8.4 would have been over there. So he would be approximately halfway in between negative 8.3 and 8.4. This is also going to help you visualize how to order decimals. So if you're going to be ordering decimal, you really want to be thinking hard about what those place values actually mean in terms of fractions. So if you're ordering 0.1, 0.01, 0.001, what you're comparing is really 1/10, 1/100th, and 1/1000th. Breaking something into 10 equal pieces is going to be larger than breaking something into 100 equal pieces, which will be larger than breaking something into 1,000 equal pieces. So as you go more to the right of a decimal place, you are talking about smaller and smaller numbers. And it can help to, think about it in terms of money, right? 0.1 is really the same thing as a 0.10, if that helps you visualize. So you're talking about 10 cents talking about 1 cent with 0.01, and then you're talking about a tenth of a cent with 0.001. So this is something you see in your day-to-day life, and it might help to sort of think about it in that day-to-day context. With that in mind, go ahead and pause your video and see if you can order these next guys from smallest to largest. So I would actually recommend sort of picturing these on a number line and how they would relate to each other. So if I have 0, something like the number 0.003, 3,000ths is just going to be ever so slightly to the right of 0. That's a pretty small fraction. It's, 3/10 of 1 cent, if you will. Then we have 0.008 is sort of the same place value as 0.003, but we're talking about a slightly bigger number. So the next number would be, and actually let me change up the colors here just because some of these might get a little smushed together. We have 0.008, just a little bit to the right of 0.003. Now we've sort of dealt with all the numbers where they go all the way to the right there in terms of their place value. So we've dealt with everybody who's just fractions of 1,000 only. Now we can look at numbers that are just a little bit bigger than that. And in particular, I would be noticing here the 0.04 and 0.043 are very, very similar numbers. This 0.04 being 4/100ths, so 4 cents if you will, while the other one is 4/100ths, so 4 cents if you will, and just a little bit more of another 3/1000ths. So if I'm going to be plotting these, I would have 0.04, and then I would have just a little bit to the right of him 0.043. This plot is not to scale, but it is in a relative sense in the order of how these would be. And then very similarly, your last numbers to compare would be 0.407 versus 0.43. So the 0.407, if you will, is basically 40 cents, so 40/100ths plus an extra 7/1000ths, while the 0.43 is essentially 43 cents. So the 43 cents will be a little bit bigger than the 40 cents, even if the 40 cents has a little bit of extra 7/10ths of a penny there. But then you would order that as a 0.43 being a little bit bigger than your 0.407. And really those would be far to the right of those numbers. And then you wouldn't be for a while until you hit $1, one full whole over here. So that helped us order that from smallest to largest, we have 0.003, then 0.008, then 0.04, then 0.043, then 0.407, and then 0.43 if we're ordering these decimals from smallest to largest. Having a good number sense for these decimals is going to help us ultimately round them. So the rounding rules are going to work the same as they did with whole numbers. So you're going to still identify the digit that you want to round to, so you want to be paying attention to place value. Sometimes they name the place value and they'll say something like the hundredths, and then sometimes they'll just say 2 decimal places for the same thing. So either way, they may call it by name or they might just tell you how many decimal places. But then you want to look to the next digit to the right. Anything that's 5 or more, you're going to round up. Anything 4 or less, you're going to round down. So let's take a look at some examples. So if I say round 3.148 2 decimal places, so that's to the nearest hundredth. What you're going to do is the hundredths place is the 4. You're going to pay attention to the 8 because the 8 is bigger than 5. This rounds up to 3.15. Sort of similarly, if we say 3 decimal places for this next number instead, that would be to the nearest thousandth. So we're wanting to think about whether or not this third decimal stays the same or not. So we're going to pay attention to the number right next to the 2. Since 4 is less than 5, it's going to round down. And what you're really doing is rounding to whichever is the closest one to it. So we're saying that 3.148 is closer to 3.15 than it is 3.14 because that 8 pulls him closer to the 5. Go ahead and pause your video and see if you can successfully round these next guys. So if we have 5.48 rounded to the nearest tenth, we're going to think about whether or not this 4 rounds up or down. Based on this 8, since 8 is bigger than 5, he's going to round up, and he's going to round up to 5.5. Nearest hundredth, that's asking about the second decimal place, and this is actually a good example where there's a little bit of double rounding going on. And what do we mean by that? Well, second decimal place is going to be this 9. Based on the number next to him, 8, he's going to round up, but this is telling us to round up, but when we round a 9 up, that really rounds up to 10, right? And we don't have a 10 that we would actually put in that place. So what's going to happen here is that 10 is actually going to add 1 to the next place. So really the nearest hundredth is going to end up being 6.8, kind of 6.80 if you will, but you probably wouldn't write the 0. And it makes a little bit more sense if you sort of picture this on the number line that we're currently have 6.79 here. The next number would be 6.80 here. And that 6.798 is right there in between, but just a little bit closer to the 6.8. So that's ultimately why he would round up to 6.8. The next one, if we're going to round to 3 decimal places, we want to pay attention to whether or not this 5 goes up or down. And the number next to him, 4, is less than 5, so he's going to round to 71.835. He's going to round down to that. Nearest hundredth for the next one, so hundredth is the second decimal place. The number next to him is a 0, so he's going to round down. That's less than 5. So you would just round that to 5,310.08. If we were rounding the same number to the nearest hundred instead, 100, don't get caught up in all these decimals we've been doing. 100 is not a decimal. Hundredths place is this 3 here. So don't always be in decimal mode just because decimals exist. This is asking a certain type of whole number to round him to. So the 3's in the hundreds place. This 1 means he's going to round down. So the nearest hundred would be 5,300. So always keep that in mind. And for decimal operations, that's going to be on the next video as you get deeper into the assignment having to do with those decimal operations specifically.